We ended part 3 by establishing that instability in RBMK reactors was their normal state, and that scientists and designers were responsible for it in not accurately understanding the reactor type, along with maximising its economy. Here we see the paragraph that is the linchpin of Episode 5's scientific narrative. HBO Legasov is right that xenon is part of the decay chain after uranium fuel atoms undergo fission, but the simple corollary that it is therefore proportional to the power level eludes his scientific mind. Instead, despite more xenon obviously being produced at higher power levels, HBO Legasov argues that high power burns it away before it can cause a problem. On HBO Legasov's slow train of thought, the next stop is that because the reactor was held at 50% power for longer, due to the Kyiv delay, xenon just kept accumulating, poisoning the core. This is factually wrong. As we mentioned in the previous part, since when or for how long the reactor was held at 50% is a critical detail. HBO Legasov claims that Chernobyl Reactor 4 was held at half power for 10 hours, with the script underlining key details. But this is not so. As we pointed out, the reduction to 50% power was actually carried out by 4 o'clock in the morning of April 25, 1986. By the beginning of the Kyiv delay, at 2 in the afternoon, power had already been held at 50% for 10 hours. The Kyiv delay extended this period by an additional 9 hours until power reduction continued at 10 minutes past 11 at night. So, what do 19 hours mean for a reactor that has had its power lowered from 100% to 50% in terms of xenon concentration? A big oopsie. As you can see, after a power reduction, xenon concentration increases in the first 4 to 6 hours, and then declines towards a lower equilibrium at a lower power level. The initial increase is because the precursor of xenon in the decay chain, iodine-135, with a half-life of 6.6 hours, takes some time to decay from its own higher concentration at a higher power level or a level of more fission occurring. It decays into xenon-135 that is now burned at a lower rate and therefore is accumulating. However, once excess iodine-135 and excess xenon-135 have started decaying, there is no source for more xenon to be produced, and both its source and itself are declining. Xenon-135's concentration consequently goes down to an equilibrium level where less of it is produced, and also burned at a lower power level, which is lower than the equilibrium concentration at a higher power level. For us, this may not be entirely clear, but it's actually basic nuclear science. And HBO Legasov makes an ironic statement in claiming that Chernobyl nuclear power plant operators, let alone an exceptionally knowledgeable senior figure in Anatoly Dyatlov, did not understand it either. So, what actually happened during the Kyiv delay? Just look at the number of control rods in the core at different times. When the power reduction began at 6 minutes past 1 on the night of the 25th of April 1986, the operating reactivity margin was 31 rods. The power reduction was essentially complete a few hours later at around 4 in the morning. At 10 minutes past 7, there was an ORM reading of 13.2 rods. This appears not to have taken into account all the rods, but clearly the ORM has declined. Why? Because in the first handful of hours after a power reduction, xenon accumulates, poisoning the reactor core, or in other words, absorbing more reaction-causing neutrons. To maintain the power level, control rods are extracted. The Kyiv delay began at 2 in the afternoon. At 3:20 in the afternoon, there is an ORM reading of 16.8 rods. At 11:10 in the evening, the ORM has bounced back up to 26 rods, well over the minimum of 15. over the course of the Kiev delay. Rather than being poisoned with xenon, the reactor core of Unit 4 was actually depoisoned. At midnight, when the shift change occurred, the night shift inherited a stable reactor with an ORM of 24 rods and a power level on the lower end of the 700 to 1000 megawatt power range found in the testing program. It's at this point we would like to give a shout out to one of our viewers who goes by the name Badass Raiding. For a few weeks now, Badass Raiding has been informing us that because we're not nuclear engineers, we don't know what we're talking about. Apparently, the about 24 nuclear engineers talking about Chernobyl Badass Raiden has been listening to disagree with and supersede the content of our videos. As an example of Badass Raiden's and his nuclear engineer's superior knowledge, is the claim that the delay caused a buildup of xenon. Badass Raiden claims that Dyatlov was smart enough to know, apparently distinct from understanding, that xenon would build up over the delay. Well, as it so happens, Dyatlov was smart enough to write things as well. In his article, How It Was, An Operator's Perspective, found in a publication called Nuclear Engineering International, Dyatlov writes the following sentence. After passing the xenon poisoning maximum, the reactivity margin began to increase, and at 2310, with the reactor at 50% power, it constituted 26 rods. We tried telling Badass Raiden him and his nuclear engineers are demonstrably ignorant of the disaster's circumstances, but he apologetically stated that is simply not true. We told him this is why we show sources and often rely on direct quotes in our videos. Badass Raiden's response was that he didn't need to post sources because it's just that simple, and in fact he framed his reaction as coming from a place of maturity. This isn't grade school, he told us. Then he proceeded to write, if you don't want to go listen to around 24 nuclear engineers around the world talk about it, then as far as I'm concerned, you're the ignorant one. And I'm glad that it's wonderful I brought up the xenon first thing, and how you said the poison it supposedly caused. It didn't supposedly cause anything. It did, it's a fact, and it's actually very simple as to why that happened. I may not be an engineer, but I am a physicist, and I can even explain how it happens without requiring a refresh course. While we do not necessarily expect an apology, we hope that Badass Raiden, who is apparently a physicist, and his crack team of 24 international nuclear engineers will take this as an opportunity to learn the layman basics of xenon transients like the one that occurred at Chernobyl over the course of the 25th of April 1986. We also hope that HBO could ask for a refund from the international nuclear engineers they were undoubtedly consulting with for the linchpin of their scientific narrative. The HBO Episode 5 script incorrectly shows Toptonov and Akimov lowering the reactor power from 1600 megawatts. As they approach 700 megawatts, at right around the stable level they actually inherited, suddenly the reactor loses around 200 more megawatts without any input from the operators. Akimov is utterly bewildered, and so should everyone else be, as even with the reduction of power from 1600 megawatts on the net, the reactor core is still being depoisoned. HBO Dyatlov, rather understandably given the bizarre circumstances, is losing his mind. So, what actually happened? To answer this question, we have to go back to the day of the 25th. This is a topic the miniseries script touches on in a single statement no one understood, very much including the writers. Notice the task between 4:13 and 12:36 on the 25th of April. Sequential measurements of the control system parameters and vibration characteristics of turbo generator number 7 and turbo generator number 8 at a constant thermal power of 1500 megawatts. Outside of the timeline, there is one other place where vibration measurements are mentioned in INSAG 7. That is page 76. We will come back to the specific event described under 1-4.7.5, when the time comes. But notice the connection between the task on the 25th of April and what the night shift was doing on the 26th. This procedure was not envisaged in the Turbo Generator number 8 rundown test program. Measurements of the vibrations of turbo generators number 7 and 8 at different loads were planned in a different program, which had already been partially implemented by the personnel on the 25th of April during alternate redistribution of the turbine generator loads at a constant thermal power of 15 to 1600 megawatts. The night shift was finishing a separate testing program, the one that had been worked on the day before. There was a double urgency to that separate vibration measurement program. The first 2 reactors of the Chernobyl nuclear power plant were equipped with turbines of the K565/3000 type, whose design and successful operation were awarded the State Prize of Ukraine for 1979. Quote, "The next stage of the Chernobyl nuclear power plant was equipped with turbines of the modified K565/3000-2 series. They tried to save some money on metal consumption with these turbines without losing the power output. Compared to the turbines of the first series, as it became known already in the first years of operation, they were distinguished by increased sensitivity to operational factors, and, as a result, a higher level of vibration of the bearing supports, an undesirable phenomenon requiring the fastest possible elimination. That is why visits by turbine specialists became necessary to carry out balancing and vibration adjustment work. And since the balanced turbine after some time again worsened its vibration indicators, the calls were repeated. Business trips of personnel from Kharkiv to Pamyat became commonplace. At the end of 1985, a mobile vibration laboratory of the Swiss company Vibrometer was purchased and began to be mastered, mounted on the chassis of a Mercedes car. It was possible to drive right into the turbine hall and conduct complex measurements of vibration characteristics of rotors and bearings. This allowed for the prompt resolution of many vibration problems for different types of turbines, and not only at the Chernobyl nuclear power plant. The plant manufactured turbines of various modifications, and not only for nuclear power plants. The laboratory literally roamed. Its personnel gained experience, and on April 17, 1986, the chief engineer of the nuclear power plant, N.M. Fomin, sent another summons to Kharkiv, which stated, in particular, the following. Since April 26th, Power Unit number 4 of the Chernobyl nuclear power plant has been taken out for scheduled medium repairs. The vibration condition of turbine units number 7 and number 8 is unsatisfactory. It was not possible to establish and eliminate the causes. Please conduct a study on the vibration condition of the turbine units using the vibration laboratory equipment before the shutdown and provide recommendations. Using the laboratory on turbine unit number 5 has yielded good results." End quote. The deputy head of turbine shop number 2, Razin Davletbayev, seems to have a rather different account of what the deficiency was. Quote, "It was necessary to measure the vibration of bearing number 12 of TG8 especially carefully. The need to perform these measurements was caused by the fact that the Leningrad plant, Electrosila, during the design and manufacture of generators for the 4th block of the Chernobyl nuclear power plant, implemented the idea of combining the design of the bearing housing and an emergency tank for oil supply to the generator bearings during an emergency interruption in the oil supply. After the startup of the block, a serious design flaw was revealed. The bearing operated with increased vibration speed. Despite the use of various measures known at the Chernobyl MPP and the Lviv Energomont enterprise, it was not possible to reduce the vibration to the values permitted by the GOST. The manufacturer, Electrosilla, whose representatives were repeatedly called to the Chernobyl nuclear power plant to eliminate the defects in the bearing, defects to call a spade, never sent its specialists, and the plant did not offer any specific measures either. Meanwhile, the vibration led to a fatigue crack in the weld of the bearing oil line, which resulted in a fire-hazardous oil leak, which was temporarily eliminated by the shop workers. I am providing such a detailed description of the situation with the bearings of the TG7 and TG8 generators so that it becomes clear why the Chernobyl nuclear power plant was forced to contact specialists from the Kharkiv turbine plant, who expressed their readiness not only to measure the vibration of the turbines, but also, using the most advanced vibration diagnostic equipment installed in a mobile laboratory based on a vehicle, to conduct thorough measurements of the vibration parameters of the TG8 generator bearing. On the night of April 26th, the vehicle with the laboratory was at the end of the machine room at elevation 0.0 in the TG8 cell. I had high hopes for the Kharkiv turbine plant specialists, since the laboratory equipment allowed diagnostics, data processing, and issuance of recommendations for balancing." End quote. Regardless what the cause and the problem was, it was significant, and there was a busy red Mercedes truck loaded with the advanced equipment most conducive to its diagnosis and fix scheduled to be there. Therefore, completion of the turbine vibration measurements program was essential. Well, page 76 of INSAG 7 tells us that the program had only been partially, rather than completely implemented prior to the night shift. Dyatlov mentions this was a task left for the night shift to complete. What remained to be done was to remove electrical load from turbine generator number 8, measure idling vibrations, and perform tests according to a separate program. Let's call it the TG Rundown program. Let's look at page 76 of INSAG 7 closely again. To complete the turbine vibration measurements, turbo generator number 8 was disconnected from the system to determine the turbine vibration characteristics during rundown. The disconnection of turbo generator number 8 from the system, together with the disconnection of the other turbo generator number 7 was stopped at 5 minutes past 1 on the 25th of April, without shutting down the reactor, meant that the EPS-5 system to protect the reactor in the event of the shutdown of 2 turbo generators had to be disabled. In order for both remaining testing programs to be completed, the remaining online turbo generator number 8 had to be disconnected without the reactor being shut down. In other words, the operators had not 1 but 2 rundown tests left to perform. This confronted the operators with something of a dilemma. Here, we can insert that single statement from the HBO Episode 5 script we mentioned earlier that wasn't given any particular meaning or inserted into an accurate context, and went over everyone's head, including the writers. I'm supposed to switch the turbine off while the reactor's still running. That was not a good thing indeed. Deputy Chief Engineer Anatoly Dyatlov wrote in his article how it was an operator's perspective. Quote, "As already mentioned, the night shift accepted the reactor at a power of 760 megawatts, thermal. At this stage, the plan called for the removal of the electrical load from the generator while leaving the reactor power the same. From a technical point of view, it is not very good to have high reactor power and unloaded turbine, but plant staff have got to accept the situation." End quote. Yuri Tregub, the unit supervisor of the shift before Akimov's, gives us a little more insight. Quote, "I tell Akimov, I have a lot of questions about this program. In particular, where to take the excess power. It should be written in the program. When the turbine is cut off from the reactor, the excess thermal power must be put somewhere. We have a special system that, in addition to the turbine, provides steam intake." Dyatlov postponed the conversation with me on the program. Here it must be borne in mind that every unnecessary intervention in the work can only harm. I had no moral right to interfere in this. After all, Akimov took over the shift, but I told him all my doubts said. A number of questions in the program. End quote. So, the problem here is if you're disconnecting the one remaining turbine at a higher power level, even at like around 700 megawatts, there is unconsumed generated steam. This was a safety concern. Tregub mentions that there was an intake system in addition to the turbines, but apparently operators had some misgivings about it. Dyatlov, while mentioning that, from a technical point, it is not very good to have high reactor power and unload a turbine, conveys that all the same it is doable, and operators should be following instructions, ironically. And so we arrive at one of the highly noteworthy curiosities of INSAG 7. On page 19, somewhat similar to what it did with completely blowing out of proportion the effect of the operating reactivity margin on the coefficients of reactivity, the international section of INSAG 7 highlights the significance of the turbine rundown test not having been performed at 700 megawatts. It is acknowledged that contrary to what INSAG 1 featured, there was nothing in normal operating procedures that forbade the performance of the test at 200 megawatts. However, without at all consulting what the power range of 700 to 1000 megawatts was doing in the testing program, who put it there and why, the authors argue that it was the operators who should have stopped and thought things out further. The international authors speciously tied the instability of the reactor to deviating from the power figure in the testing program. As we have just seen, the operators were not unable to achieve the prescribed test power level. Previous operation at half power had set them up perfectly, and the night shift didn't even need to change the power level. There are two events being commonly conflated in power level discussions. One occurred at 28 minutes past midnight, a clear drop of power. But the power level at that point was already significantly under 700 megawatts, at around 500 megawatts. Our focus in this video is on the events around 5 minutes past midnight, just as the night shift assumed control of Reactor 4. The big mouths of INSAG 7 are suddenly silent. According to the HBO Episode 5 script, without any intervention on the part of the operators, the reactor core powers itself down from around 700 megawatts to around 500 megawatts. This is the ubiquitous xenon poisoning driving the episode's narrative, but we know the opposite to be true. INSAG 7 provides no answers whatsoever, except a slight mysterious elaboration in the second timeline on page 112 towards the end of the report. 0005. Thermal reactor power 720 megawatts. Steady unit power reduction continues. A steady unit power reduction taking the reactor core under 700 megawatts, and thus under the power range of the rundown testing program, continues. We know the operators ran into a dilemma between the power range of the testing program and a safety concern of keeping the reactor running at a higher power level while disconnecting the one remaining turbine, so as to perform their remaining tasks. Anatoly Dyatlov and Yuri Tregub both claim a decision was made to intentionally reduce the power level, but frustratingly involving a different pair of supervisors apparently having an argument. According to Dyatlov, there was a disagreement between unit shift supervisor Alexander Akimov and plant shift supervisor Boris Rogozhin. According to Tregub, it was Dyatlov and Akimov having the same argument. Tregub claims Dyatlov wanted the power level to be 200 megawatts to begin with, whereas Akimov was remonstrating with the testing program in his hands. Tregub didn't actually hear the conversation, but observed it, and so he concluded This makes me think that the power reduction was carried out at the direction of Dyatlov. So we know, according to the two supervisors, what the issue and the outcome was, but the details are frustrating. Neither agrees who made the decision to deviate from the testing program, and neither makes a very explicit connection to the turbine vibration measurements. The Hallmark public expert reports skip the matter entirely. You can see the aforementioned obscuring conflation of separate events in INSAG 1, for example. After the delays initiated by the system dispatcher, the further conditioning of the plant for the test recommenced late on the night of 25th of April, involving a reduction of power towards the test target level of 700 to 1000 megawatt thermal. This proved difficult because of the mishandling of the control system by the operator. As a result, reactor output fell to a low level. To emphasise, the power drop event occurred later at 28 minutes past midnight from a power level of around 500 megawatts. There was no difficulty in reducing the power level to the testing program range. The vibration measurements are never mentioned in the 1986 Soviet report to the Vienna meeting or in the resulting INSAG 1 report, and their mention in the available Politburo notes is related to another event further down the line, with their timing being apparently incorrect. In other words, we need further substantiation for what happened at 5 minutes past midnight when the reactor power level was about to deviate from the power range in the rundown testing program. That's where a person known as Papitum, spelled Papitum, on Reddit and various Ministry of Media machine building variations on YouTube and Discord came to the rescue. First, he dug up this. This is an internal 1986 report on the causes of Chernobyl by the Soviet Ministry of Energy's All-Union Research Institute for the Operation of Nuclear Power Plants, VNIIAES. On pages 158 and 159, we find the following. The initial state is described as the reactor being stabilized at 700 megawatts thermal, a highly significant statement on its own. However, it is written that there is an understanding that after the disconnection of the second turbine, there isn't a place to release excess steam, and this was not provided for by the test program. Then the report goes on to consider three alternatives operators had to choose from. Alternative A is to reduce power to a minimal level. Confusingly, it appears the reason written here is reducing steam in relation to AZ, which we're not sure what to make of. The consequences are reduction of pressure release and conducting tests according to a corrected testing program. Alternative B is conducting tests at 700 megawatts because that is what is written in the testing program. The consequences are a significant pressure release and difficulties in stabilizing the reactor. Alternative C is a refusal to conduct the tests due to understanding the incorrectness of the testing program, with a consequence of planned tests will not be conducted. The choice the operators made was A, with a motivation of confidence that the tests should be conducted at a lower power level. It was during this further power reduction that a problem occurred. What is the assessment of this report of the action by the operators? It was the correct decision. Then Papitum decided to dig up some other things. This is a COM switch, and not just any COM switch, but the one that was used on the 26th of April, 1986, at Chernobyl Unit 4 to release the control rods under their own weight into the reactor core, as a last attempt to shut it down. What you see on the left-hand side is an operating log, bolstering the authenticity case for this item. Well, what we care about is a particular line from it. It's hard to see, but we believe what is stated here is the following. 5 minutes past midnight. By order of the NSB, Unit Shift Supervisor, or in this case Akimov, power reduction has begun. Papitum then found this, a newspaper article by Station Shift Supervisor Boris Rogozhin. Here, we can see far more legibly 5 minutes past midnight, power reduction started by order of the NSB, Unit Shift Supervisor. So, what we have is not an accidental or forced deviation from the power range found in the testing program, but an intentional one. We have considered why this deviation would have occurred, but we have not considered the power range in the testing program. Who put it there? Why? And why would the operators deem it acceptable to override it? One of the ways in which the operators were attacked after the disaster was with the charge that they did not coordinate the rundown test with, and get it approved by other organisations like NICIAT, the Kurchatov Institute of Atomic Energy, and some others. Page 52 of INSAC 7 points out, however, regulations NSR 0474 and GSP 82, which were enforced at the time of the accident, did not require the plant managers to obtain approval for such tests from the aforementioned organisations. This line of attack now turns on the people who were using it. If the rundown test was conducted too independently, does that have any bearing on what the 700 to 1000 megawatt power figure was doing in the testing program? Enter Anatoly Dyatlov. In his article, Why INSAG Has Still Got It Wrong, Dyatlov drops the following bombshell. I set the 700 megawatt level when I drew up the experimental program at Chernobyl, and it was based on incidental considerations. At the time the program was drawn up, it was assumed that we would be checking the main safety valves, for which considerable power was needed. The capacity of a single valve is 725 tons per hour of steam. Since performance of the turbo generator rundown program was placed right at the end, because of having to place most of the mechanisms on reserve power, these are the safety measures which the program was criticised for lacking, and the reactor was being shut down for this. In order not to have to wait for a falling power, the level for the proposed proceeding work was entered. After the unplanned reactor power dip, I took the decision to keep to a rise of 200 megawatts in view of the adequacy of this, and not because of the impossibility. Surely it is obvious that with a positive fast power coefficient, there are no limitations on raising power. Of course, it was borne in mind in taking this decision that 200 megawatts is the usual power level permitted by the regulations. Dyatlov goes further in his book. Power level. Per the program, power level was supposed to be 700 to 1000 megawatts. Prior to its performance, our power was 200 megawatts. Why was this? I will discuss that further. But what a bone we have thrown into the teeth of our accusers. And still they continue to chew. Even the Soviet informants to the IAEA were brought to sin. They, being poor and tempted with the chance to pour mud on the personnel, under the leadership of Valery Alexeyevich Legasov, in front of the entire world, lied that regulations prohibited operation less than 700 megawatts. Why did they do it? Simply because after the accident, it became clear that low power for the RBMK 1000 reactor was the most dangerous. So, what would we do without the academics and doctors? We have to get out ahead of them. Who would suspect such a reliably viewed person of a lie? There are programs for which power level has significance. For instance, testing of the main safety valves at a low power is not allowed, since with the opening of the valves, primary system pressure starts to decrease rapidly, and damages the main circulation pumps. For the program of TG rundown, power level doesn't have any significance. And with the start of the test, we were going to shut down the reactor. See section 2.12 of the program. In accordance with station instructions, power should be indicated in the composition of the programs. In the composition of the program, it was not clear what we would be doing immediately before the test, and established 700 to 1000 megawatts as the maximum, not the minimum power. When power fell with the transfer of the regulator, there was no need to raise it. And for a normal reactor, performance in accordance with the NSR and GSP didn't matter. We violated nothing, despite all the allegations of the Commission and informants. Dyatlov claims that the power level found in the testing program was a clerical necessity, a figure to put on paper. Dyatlov claims it had nothing to do with the safety or indeed the validity of the test, and correctly points out that Soviet experts had to ultimately resort to lying in Vienna that a normal regulation existed against operating under 700 megawatts. That power figure was found only in the testing program, and Dyatlov claims to have put it there himself. Therefore, when circumstances changed, operators would have been inclined to regard it as changeable. Finally, we arrive at 28 minutes past midnight, which is where part 5 of our miniseries on episode 5 of the HBO miniseries will begin.